Hey everyone, Kyle Walker here. If you love cars, fixing things, or just want to understand your vehicle better, you're in the right place. I share hands-on tips, smart driving advice, and straight-up car talk without the fluff. Make sure to hit that like button, subscribe to the channel, and stick around till the end. You don't want to miss what's coming up. Let's get into it.
Most modern vehicles are equipped with internal combustion engines, the fuel for which is gasoline. It was learned to make it back in the 19th century, when it was extracted by primitive distillation methods. Since then, technology has advanced, but the basis for the production of gasoline is still crude oil. How much fuel can be produced from a barrel of crude oil? Even though cars are all around us in huge numbers, few people have a thorough understanding of how much gasoline is produced from a barrel of oil and how it is produced. The main technological process is the so-called distillation, after which auxiliary products such as fuel oil, kerosene, and even diesel fuel are extracted from the residual oil products. Despite the fact that for us the physical measure, 1 ton, is more familiar, in the field of petroleum products another unit of measurement has become widespread worldwide. Therefore, when we want to understand how much gasoline is obtained from a ton, we must first remember that each ton contains about 7 barrels, each of which contains approximately 159 liters of oil. The technologies that are used at American refineries have allowed them to increase the volume of the product at the outlet by another 9 liters. Thus, they have 168 liters of petroleum products from a barrel of oil. Let's see how much and what can be obtained, based on the product category from each such barrel, about 5.5 to 5.6 liters of a combustible substance known as fuel oil. It is indispensable for heating, but it is also used to fuel ships and locomotives. Almost 21 liters of aviation fuel. For a modern aircraft, this is a very small volume, on which it will not be able to fly even a couple of kilometers, 8.5 liters, of solid petroleum coke, which is a product of secondary processing. It is used in the production of ferroalloys, electrodes, and in a number of other cases, about 9 liters of gas, which is produced. During the distillation of petroleum products, 25 liters of diesel fuel, which is commonly used to fuel diesel cars, trucks, and agricultural vehicles, 85 liters of gasoline. That's how many liters it contains in one barrel. For most mid-range autos, this volume is enough to cover about 1,000 kilometers of travel for 1,500 milliliters of gas, which acquires a liquefied form. This product is actively used as an automobile fuel for heating appliances in the manufacture of aerosols, a dozen cylinders filled with propane or 1.5 kilograms of briquette charcoal, 1 liter of automotive motor oil. That's the yield of a barrel of oil. These are not the only uses of oil and its derivatives. They are also used to make components needed by the pharmaceutical and cosmetic industries, chemical, and even food industries. How gasoline is made in industry. Pure oil extracted from the Earth's interior or offshore is used for production. It has a couple of main components, about 85% carbon and about 15% hydrogen. In the process of combining them, hydrocarbons are obtained, on which the direct distillation process is based to create gasoline in the industry. There can be several such processes, and each of them is based on different technologies. However, the most common among them are platforming, cracking, thermal, or catalytic. At the dawn of the development of petroleum products by man, direct distillation was the simplest chemical process, which, if desired, everyone can master at home. It is based on heating of oil, in the process of which separate components are vaporized from it and different petroleum products are obtained. Raw materials are placed in a closed container, to which a gas vent tube is connected. How to make gasoline from oil? Simply by heating it to the following temperatures. Gasoline condenses through the tube from 35 to 200 degrees Celsius. Kerosene is released at temperatures between 150 and 305. Diesel begins to form between 150 and 360 degrees. Read also, what is reversing and how it works. The condensate is then isolated in a separate container and cooled. However, despite the apparent simplicity of the process, it does not produce much fuel and is therefore characterized by low economic efficiency. The yield of finished petroleum products from 1 liter of feedstock does not exceed 150 milliliters. In addition, The octane number will be very small, no more than 50 to 60 units, and such fuel is not used now. To increase its value, we will have to add a lot of additives, which will make production even more unprofitable. On the basis of such a process of gasoline production from oil, it will not be possible to create industrial production. The process of so-called direct distillation of crude oil is known as the main method that is widely used in modern industry. It is nothing but the separation of raw materials into separate fractions, which differ from each other in characteristics. The process of direct distillation of oil to create gasoline in its refining looks briefly as follows. Oil is heated, after which its vapors are released. They, as well as condensate, are taken away in separate containers. Thus, it is possible to obtain fuel distillates and fuel oil, from which lubricants are subsequently produced. For these purposes, the industry uses continuous units in which vaporization and further separation of distillates into fractions form a single technological process. The vapors are further condensed and transformed into liquid gasoline. Its yield in the distillation process can reach 3 to 15% of the initial volume of raw materials used. Modern industry uses catalytic and thermal cracking of oil. The first method has been widespread since the beginning of the 20th century. Its essence is to split the feedstock into separate fractions with a lower molecular weight. Among such fractions are certain types of petroleum products, gasoline, oil, kerosene, diesel fuel, and so on. After the formation of lighter fractions, the most stable ones remain, the burning temperature of which reaches 350 degrees Celsius. Gasoline obtained by cracking is characterized by higher qualities compared to that produced by direct distillation. This is due to the fact that it retains more varieties of hydrocarbons. Both cracking processes can be characterized as follows. Thermal, splitting occurs due to exposure to high temperature, up to 550 degrees Celsius. Catalytic, splitting occurs due to the presence of catalysts in the process. The second method is considered to be more progressive. This method produces fuel with a high octane number. Deeper and higher quality of oil refining is guaranteed. Vacuum gas oil is used as the main feedstock for catalytic cracking, while other feedstocks require preliminary preparation. The basic catalyst for the cracking process is aluminosilicates. Read also, AGM batteries, device, operation, the subtleties of charging and thermal cracking. The most important conditions of the technology are the operating temperature, reaction duration, and pressure level. With this method, petroleum products with smaller molecular weights are treated. For example, this could be coke or some motor fuels. In order to achieve high-quality polymer products, it is important to ensure pressure changes to be able to quickly influence the secondary reactions taking place. In addition to thermal and catalytic cracking, oxidative and electrical cracking are also known. Fuel octane number. Another indicator that every driver has had to deal with is the so-called octane number. At gas stations you can see different numbers, for example, 76, 92, 95, and so on. The main definition of this concept is the resistance of fuel to detonation. The higher it is, the longer the ignition process will be, and, therefore, the more the fuel can be compressed before ignition. This increases its efficiency because more energy can be obtained from the fuel in such cases. Car engines are produced that are specifically designed for gasoline, which can be compressed for a long time, without the risk of explosion. This process is carried out directly in the combustion chambers. Such fuel is called high-octane fuel, and it is obtained at the industrial production of gasoline by adding special additives to it. You can measure the octane number with the help of a special measuring device called an octanometer. However, this indicator will only be approximate. For a professional measurement, laboratory research is required. This can be carried out by one of two methods. Research, in which the fuel is compared by its indicators with the standard, motorized. This uses a single-cylinder internal combustion power unit that can vary the compression ratio. How can the octane number in the production of gasoline in petroleum affect engine performance? Gasoline with a low number will ignite faster, and this leads to its increased consumption and low efficiency of the engine. Fuel with a high number of octane has opposite qualities. The efficiency of the engine increases, the consumption decreases, albeit slightly. Much depends on the design values for which a particular power unit is designed. If the car, for example, is designed for 95th gasoline, and it was filled with 92th, the fuel consumption will be higher. In the reverse situation, the motorist will not get any tangible gain. In order to understand the expediency of using more expensive high-octane fuel, you can pay attention to such an indicator as the compression level of the engine. There is no point in refueling with high-octane fuel if the car is not designed for it. The only consequence will be readjustment of the intake and exhaust gas system. The technologies of gasoline production, increasing its characteristics, are continuously improving. They are necessary also because car manufacturers are developing more innovative, economical engines that require efficient fuel for their work. In conclusion, understanding gasoline production is essential for grasping the complexities of our energy landscape. From traditional refining methods to innovative techniques, the journey of crude oil transforming into gasoline involves intricate processes that yield significant amounts of fuel. Typically, 1 barrel of crude oil can produce approximately 20 to 25 gallons of gasoline, highlighting the efficiency and importance of this resource. As we continue to explore sustainable alternatives, the knowledge of gasoline production remains crucial in navigating our energy future. Thank you for joining us in this exploration of gasoline production methods and their implications.